Welcome students and learners. Today we're discussing conic sections. Great topic here. We're dealing with graphing, some algebra 2, pre-calculus. What we're looking at basically is what a flat surface would do if it was cut through a shape or a 3D. I'm giving you some dashes here so you can see a 3D shape. What would happen if you take this flat surface, which we call a plane, and cut it through this cone? What shape would it create? What section? And basically using this plane and creating some sort of coordinate plane to go with it, and what shape or what curve are we going to see if we cut this cone? So first I want to introduce you to a math artifact here from 1991. Seems distant past there, but we call this, our conic section demonstrator. And what it's doing for us is showing us some of the shapes what we get when we cut this cone into sections using flat surfaces. And I'm going to be able to show you that when we I've created some flat surfaces for you. Basically, I've created this plane, and then I'm going to show you how this fits onto a cone to give us the shape of, let's say, a circle. So let's look right away. Now, we're going to be looking at this kind of double cone feature here, and we'll be using some slashes to show us the 3D aspect of it. Our first circle really doesn't use, or this other cone doesn't come into play when we talk about parabolas and hyperbolas. It will more so. But what we have in this is basically, okay, we're taking this plane, like I said, and we're cutting this cone. We're going to cut this cone with a plane parallel to this base. Give you some slashes there so you see it's behind. And by doing this, what this does is actually going to create a shape for us here. It's going to create a shape there. And this shape is what's going to be our circle. And basically, we're now creating that kind of set graph there, and we're looking at this on some sort of graph. Now, let me show you what I mean about cutting this cone with a flat surface. Basically, I'm like a math fruit ninja. Basically, I'm just slicing this through this cone here, okay? And if I put the top piece on here, basically I'm cutting this, and I'm cutting this conic section right through the cone here. And you can see when I do that, I create this circle shape here, and I've cut through the cone. And you can see when I take this top piece off, what that looks like here. And then you see how it's kind of cut through in that flat surface that's created there. I'm just going to use a single cone here. Talk about another shape. This way you can kind of see what I'm doing with the instrument that I'm using. And I'm going to take another flat surface, but this time I'm going to put the plane on an angle. And you'll see what happens is we kind of get a different shape here. And because this tilts, our circle is now going to stretch and look more so like an oval. And this is where we get this ellipse shape that we talk about. And again, the graph kind of gets put on there, and that's where you talk about your X and Y coordinates, and then your flat surface. So this flat surface has cut the cone, and I'd like to show you that. I keep dropping this top piece. And I'd like to put an ellipse on this cone. So basically, I've cut this cone and created this ellipse shape, and that's the ellipse you'll see on in some of your math textbooks and shapes. Now, sometimes this ellipse can be written as a vertical ellipse, which we have here, or sometimes it could be seen as a horizontal ellipse, which we have here. And I've actually given you the equation for each, some of your horizontal and vertical ellipses here. And if I take this flat surface off, you'll see that's where this ellipse shape comes from. You can even see the piece we've cut off kind of also has that ellipse shape there. Now continuing on, we're going to look at a double cone here, right? That was not a good curve. We're going to look at a double cone here, and we're going to create, by cutting a flat surface, not cutting from one side of the cone to the other, actually taking a flat surface and cutting it through the bottom of the cone here. Give myself 2 cut points, right? Take my flat surface and cutting it through the bottom of this cone here. Let me make sure this is parallel to this. I'll give you some slashes so you can see it's kind of behind. I'm going to create that shape which we see so much in math. I'm going to create create that parabolic shape there. And this is coming through the base. Hard to see on a board when I'm drawing in 2 dimensions. But if you have a tool from 1991, I don't believe to have had a cell phone at that point. But here you go, we're taking this piece of paper, this flat surface, and we're cutting it, and we're creating that parabola shape which I've shown you here, right? And you can see that on the piece that we've cut out. Now if I reconnect this piece here, you could see that this is what we've created when we've cut it through, and you see it's cut through the base, and because it's cut through the base, the section that we're kind of only looking at, this parabola, this infinite direction it's going is created by this parabolic shape that we've created by cutting this parabola out of our, as I call this, the conic. We call this the conic, the 91 cone section demonstration model here. We call this the conic. We're going to name this the conic. Now, last one we're going to take a look at, I'll erase this here, is another double cone, but this one, it's funny, each time I draw these cones, I just draw them a little bit differently, using a couple different lines. What I'm going to do is, this flat surface I had on an angle, this one I'm going to draw perpendicular, create perpendicular to both bases. So it's going to meet at a 90 degree with both bases. And I'm going to do it on one side of the cone here. Okay, it'll come through the bottom. Let me give you your dashes so we can see where it's behind. And basically, what we've done is we've created two identical curves through the bottom piece of each of these cones. Okay? Again, hard to demonstrate on the board. Close, we've gotten it close, but if I had my conic, as I call it, this piece is always a little difficult to get off. You can watch me struggle with it if you want. Yeah, I was figuring maybe during this, if I should have gotten some sort of pry tool, but here's your parabola. Here's our flat surface. Here we're cutting it through our cone, and we're creating one part. And if you see, I actually drew, if it was going to intersect the other cone, I drew that other piece of it, and that's what we're looking at here on the board. We're cutting this cone down the side here and creating this shape right here like this. This is your hyperbola right here. This is our hyperbola section, which has 2 identical curves on either side of the cone. And this is where we kind of start to look at all these 3-dimensional figures we've created, such as our hyperbola, and put them onto a 2-dimensional graph, which is our plane. We've taken this section out, now we're putting on a 2-dimensional graph. Here's your circle we've looked at. That would be on your XY graph. Here would be maybe an example of an ellipse. Again, it could be vertical, and then maybe we just put a parabola here. Ours was facing downwards, so we'll do the same. This would be your parabola we're looking at. And these are the 4 basic conic sections you could look at by taking a plane, cutting it through a cone, and coming up with some section. Remember, math is easy when you work hard.